Great to see you here again in this new video. In this new video, I'm going to talk about matrices. What is a matrix? Why is a matrix important in discrete mathematics? Why do we use it with algorithms, and what algorithms are we in fact using to deal with operations of matrices? Now, first of all, the importance of matrices. Like I said, matrices are very important in discrete mathematics, and it's important that we spend some time on the subject of matrices because we will be using them later in this course. Matrices are typically used to express relationships between sets. And a very common application of matrices relate to communication models and transportation systems. Now, when you look at communication, what's happening in the communication network, the routers and the switches contain information about the network, and they contain that information in a matrix form. They are in fact keeping information where to send a package to the next hop. And that's very important because we have to find out when a package with some IP address which is sent to an IP address, we have to find out where do we find that IP address, what is the subnet, and how do we send that package through the network in the most efficient way. Now, there are a lot of algorithms that will be developed that are using matrix models. So matrices are very important, and they are also very complicated because the number of operations when we're calculating with matrices, the number of calculations increase exponentially, even with the simple multiplication of two matrices. It is clear that reduction of time finding, let's say, efficient algorithms is very important. And when we look at the complexity of matrix calculations, a lot of different algorithms have been developed that deal with those matrices and that identified ways to reduce the number of calculations that have to be done. That's a part of algorithms. We are going here to define what matrices are about. First of all, we have to define what the matrix is. And the general definition of a matrix is in fact a rectangular array of numbers which is organized in rows and columns. An m times n matrix is a matrix that has m rows and n columns. And when the number of rows and columns is the same, we call it a square matrix. Now, we can also define when two matrices are equal. Basically, two matrices have two conditions to fulfill in order to be equal. First of all, they have to have the same number of rows and columns. It doesn't mean that they have to be square matrices. No, m and n can be different values, but a matrix is m times n. It can only be equal to an m times n matrix, not to an m times n matrix, although the number of fields would be the same. Now, the second rule to see that a matrix is equal to another one is that all the entries, the corresponding entries in all the positions, are equal. Let's have a look at two matrices here. I made them square, but it's not necessary. So we have the matrix A, which is an n square matrix with the column 1, the first column having elements A1, 1 up till AN 1, right? N is the number of rows. And we look at the last column, we have A1N till ANN, which is in fact all the elements in that last row. The second number indicates the column, and the first number indicates the row. Now, we already know that the two matrices have to be the same, type, so both have to be square matrices, and the number of columns and lines and rows have to be the same. Now we can say that A is equal to B if for all I and j, when I is equal to j, and aj is equal to bij. So basically, we have to find for all those numbers, we have to find that the elements in this matrix, that they are the same for every element. So A and A11 has to be equal to B11, up to A and N has to be equal to B and N. Now we can also describe some more terminology related to matrices. Let's consider an m times n matrix. So we have A, which has m rows and n columns. We can define the jth column, which is given by a1j up to amj. For example, when j would be the third column, we would have here a13 up to an3. And the ith row is given by the sequence ai1 up to ain. If I would say I consider the fourth row, I would say this is a14 up to ain. Sorry, it would be a41 up to a4n. Sorry for that. Now, what we look at, the elements of those entries in the matrix, we have to say that they're characterized by their indexes I and j. And when we have an element aij, it means that this is the element of the matrix which is in the ith row and the jth column. For example, a3, 4 would be in the third row and the fourth column. And we can also write the matrix as A is the matrix composed of the elements aij. And that's in fact a, let's say, more simple description or notation of a matrix. Of course, we have to specify what are the number of rows and the number of columns. So we have to specify m and n. This was about the introduction to matrices. We will continue with matrix operations. We look at sum and products and some other operations in the following videos. Anyway, you're doing a great job. I'm looking forward to seeing you in the next presentation. Thank you and bye-bye.